So we're going to extend our conversation on polar points to include simple polar equations. Now this is perfect because an equation really is just a collection of points, which ultimately turns out to be some type of graph. And so what we want to do is we want to figure out what kind of graphs do we get when we maybe graph an equation like theta equals 105, or as you can see, r equals 5. Well, let's find out. And the first thing really to realize is that, again, theta equals 105 is not just a single point, but it's a whole bunch of points. And really, it's a whole bunch of points where theta equals 105. So maybe we should figure out where 105 is. Now, keep in mind that on this graph paper, each one of these lines is 15 degrees from the previous. So we quickly can land on the line of 105. But what points would have a theta value of 105? Well, that point would, but just the same as this one and this one. You see, each one of these points that I'm plotting has a theta value of 105. It just so happens that the radius is changing. But that's all right. We just want to make sure we have theta equals 105. What if we're on the opposite side? Is that okay? Well, it would be okay because the r values over here would just be negative. And so I can continue to plot points where it appears that we're getting an entire diagonal line that would represent theta equals 105. In fact, when I connect the dots and make that diagonal line, I've officially graphed the equation theta equals 105, which again would be a line. It would be a line. What would be some other ways that we could describe this line? In other words, what would be some other angles? Sound kind of familiar? Well, yeah, because I could rotate, well, maybe like around to the back side of this line. Now, if I'm going to rotate around to the back side of this line, it might be helpful if I think about this this little sliver of an angle right here, this 15 degrees, as transferring nicely down here to the back side, so that when I rotate all the way around here, I can just simply think of adding 15 degrees to my last little checkpoint, which of course is 270. But technically the equation would be theta equals 285. What would be another way that I could rotate to this blue diagonal line? What would basically be another way that I could describe this angle? What about if I rotate in a negative manner? What if I rotate, down here? Now, again, that's a negative rotation, so that means that, I'm 15 degrees. Remember that 15 degrees that we had marked here? I'm 15 degrees shy of negative 90. And we could call that theta equals negative 75. And then, of course, there's one more way. That would be the way that rotates negatively, but rotates negatively all the way over to this side again. Keep in mind your negative rotation. Up here would be negative 270. So I'm just 15 degrees off of that, which we could call theta equals negative 75. No, not negative 75, negative 255. So just like you can name a point different ways, it looks like we can also name this line some different ways. But ultimately, when it comes to graphing this line, we want to keep in mind that that's exactly what it was. It was a diagonal line that was represented by the equation theta equals 105. How about this other equation down here? Let's get rid of some of this. How about the equation r equals 5? It is also an equation, so that means that it's a collection of points, and I guess we just need some points where r equals 5. Like this point right here. That has an r value of 5, but so does this point and this point and this point. In fact, the truth is every point, as I keep working my way around what? Yes, around this circle, would have an R value of 5. And so technically what I'm really graphing is a circle. Technically, it's this line that I'm drawing. It's this circular line that would represent the equation R equals 5. So we have two simple equations. One of them that creates literally a diagonal line, and the other one that literally creates a circle, but both of them can be graphed. Why don't you try? Make sure that you've picked up on what we're trying to say here. That is, if you can graph a simple equation. So again, go ahead and give it a shot. Great time to pause the video. Just make sure that you've got the learning before we move on. All right, so did you rotate negative 45? That would just be like rotating down, of course, to get to this line. But when we get to this line, known as negative 45, we want to realize that we can actually draw it to both sides. If I could draw it straight, that would be nice. But we draw it to both sides, which technically would be the graph of theta equals negative 45. Of course, there's some other ways that you could name this graph. If I wanted to, I could actually do a straight up positive rotation. Starting at 0, I could rotate around here. That would be 135, but really that means my equation is theta equals 135. I could keep rotating around, right? I could keep rotating around and just get all the way around to this back side. That would be a positive rotation, but that'd be all the way around to 315. And then there's just one rotation we haven't shown yet. That's a negative rotation. Notice that I am starting back at 0, but I'm rotating backwards. So it's a negative rotation. We can call that theta equals negative, what, 225? Each one of those equations represents that same line. And how'd you do with R equals 4? Probably a little bit easier, right? Because, well, you're just plotting points. In fact, you're plotting all the points where R equals 4. So I think we're in here just plotting the points that represent this circle. You can actually just draw the circle since the equation is actually the collection of points. Simple polar equations create some simple polar lines. Now, normally what we would do today is give you an opportunity to keep practicing this concept of plotting points and trying to name them different ways. And I'm going to ask you to go ahead and do that. It's something that you'll submit, and it's ultimately to get you ready for the mini check. Yes, there's going to be a mini check for the next day.